Hi, this is Steve French. I'll be talking about the very exciting progress on the Linux SMB3.1.1 client. And during this talk, I'll be talking about many exciting features. But first, let me give a description of who I am. For those of you who aren't familiar, I'm the maintainer of the Linux cifs.ko module, which is the SMB3.1.1 client. Used for accessing Samba, of course, but also Windows, Macs, and the largest file server in the world, Azure. Also the co-maintainer with Namjay of the kernel server, ksmbd, and member of the Samba-Team for many years. I work for Microsoft in Azure Storage. It's a very exciting time. So I'll be talking about the Linux file system activity over the past year, just at a very high level, and then zoom in on and talk about specific client improvements to the SMB3.1.1 client, and then also talking about what's coming soon and what to look forward to, and then talk about one of the most important things, which is testing, getting quality as good as possible. So what was it a year ago? A year ago, we were at the 6.9 kernel when we were talking at sambaXP, when I was talking last year. Now we're at the 6.14 kernel. Linus likes to choose crazy names for these releases. And I'm not exactly sure why we have a baby opossum posse, but that's where we are now. So the 6.14 release was smaller than some. Now over this 1 year period, the activity, the kernel was down slightly and the number of files changed was down slightly, but that's still huge, 65,000 change sets from over a couple thousand developers, 3,700 files changed, almost 3 million insertions. The amount of activity in the Linux kernel is staggering. Now, a few weeks ago, we just had the Linux File System Summit in Montreal, but last year it was in Salt Lake City. And it really is exciting to work with this talented group of Linux kernel developers working on storage and file systems. You can see a picture here from a year ago. Now, at the File System Summit, and if you follow the FS Develop mailing list, you can see that a lot of the activity is, as you might expect, things like testing, right? Automated testing. Two of the talks at the File System Summit a few weeks ago were about automated testing improvements. There's also obviously continuing talks on how to improve the mapping layer between file systems and the new folios, variable size pages and the very cool memory management features that Linux has. NetFs is the mapping layer between that and network file systems. But it's also interesting to see this continued work on improving FS cache and improving page caching in general. Now, one of the things that really fascinated me at the File System Summit a few weeks ago was the new ways they're handling file system change notifications, sometimes leveraging eBPF. Obviously, ID mapping and containers has been important. There was a talk about moving to Rust, how that's going to work, and it had much less pushback this year than last year. Last year there was a lot of drama about the discussion of how Rust could gradually increase its presence in file systems. There were a lot of good questions on that. I think that it's going to proceed very slowly in the Linux kernel, but it is something that I think you're going to see continued improvements for. If you look at the 6.15 release candidate that's in process right now, I think you're going to see there were quite a few improvements to Rust already just in that release. Now, they finally finished up the conversion of a lot of the older file systems to the new Mount API. And one of the things that you're going to see, and we saw it a lot at the File System Summit a few weeks ago, is discussions about how to leverage eBPF more. This not just for dynamic tracing, but for other purposes as well. And I gave a talk last year at the Storage Developer Conference on Quick. There's a Red Hat developer who's been doing some great work on producing an in-kernel driver for Quick, sort of like what Windows has. And it's a very impressive concept because Quick, being able to support encryption for network traffic in the kernel, can be very, very helpful. And interestingly enough, it also showed some performance numbers that when Quick is unencrypted, it's faster than TCP in many cases. And of course, there continue to be discussions about the shift to the cloud and better support for faster storage and RDMA. Now, looking at over the past year, the file system activity, it represented 9% of the total kernel change. That's more than double the lines of code. So it's a much more active component, these file systems, than the rest of the kernel. It is a decrease from last year, but a huge increase from previous years. Now, there's lots of developer attention on file systems. The Linux kernel file systems are almost 1.2 million lines of code, just measured last week. And there's been a lot of progress over the last few years. Now, let's mention some highlights. ksmbd is no longer experimental as of the 6.6 kernel, the ksmb server. Now, there's been a lot of drama about bcachefs, but it was interesting new file system added in 6.7. NTFS Classic was removed in 6.9. Now, interestingly, ext2 is now tagged as deprecated. They're not going to remove it yet, but it can't support dates past 2038, so don't be using ext2. And the old NTFS, removed in favor of NTFS v3, but they've also marked RiserFS as obsolete, and it was removed in the 6.13 kernel. And just now, the System 5 file system was removed in 6.15. Now, will JFS be next? I saw some change sets for JFS just go in, but we're removing some of the out-of-date file systems. Now, what were the most active Linux file systems over the past year? Now, the VFS layer itself gets a lot of changes, 440 changes. That was similar last year and this year. But the top file systems in the VFS really, truly just dominate all the activity. Now, what are the most active local file systems? Well, bcachefs. A lot of bugs for it to work through. Btrfs, it has a huge number of features. And xfs. XFS activity was up a lot, by the way, this last year. So those three file systems generate a lot of activity, but what's next? Well, my SMB client. The most active non-local FS is cifs.ko, almost twice as active as the NFS client. And there are also many, many more lines changed. It's been a very active year again for cifs.ko. Now, ksmbd server activity has been down somewhat, but I think you saw that Samba activity has been up quite a bit, and it's been a very exciting time for Samba server. But one of the messages from this is that a lot of attention on XFS, BTRFS, and SMB client. Now, those 304 change sets are for 65,000 lines of code, not counting the user space utilities. That's a lot more lines changed than NFS did. But I want to thank the many great contributions from lots of different developers, some of which are attending the conference. Now, note that Samba as a server is literally, 100 times bigger than many of its alternatives. 4.1 million lines of code. It's much more active. It includes key security services and not just file server, but a lot of tools as well. Now, I've talked about this before, the goals. We want SMB to be the best, most secure general purpose way to access file data. Sort of your lingua franca, the general way you just access data, whether it's in the cloud or on some small embedded device. There's a lot of cool things to do, improve directory leasing, improve compounding, take advantage of some SMB features that have been around a long time. Now, one of the problems we have with Linux is that the Linux file API just keeps growing on you. In the day of POSIX, when POSIX mattered, the number of API calls in POSIX grew very slowly. The Linux file system API is, 5 times bigger, 10 times bigger than POSIX. It's kind of insane to look at. Now, if you look at the just the new syscalls, there were 5 added since since my talk last year. And in addition to syscalls, they added new ioctls and new fsctls as well. And a lot of these, they're not just some weird esoteric thing. They can be very, very useful. There are also additional flags and things like that added and additional features to some existing syscalls. But, think about it. We have 5 new syscalls to deal with. Linux API it keeps growing. And one of the things we have to keep being aware of is, what does that mean for SMB? Do we have things we need to add to Samba and ksmbd in the Linux client? Now, talking about interesting drama, remember bcachefs? There was a fascinating discussion a few weeks ago at the LSF Storage Summit. Remember, the developer for bcachefs was briefly banned. They talked a lot about, good behavior and how to deal with, drama and open source. But bcachefs could be very exciting. Now, one of the really exciting things about SMB3.1.1 is the broad interoperability testing. We have so many different servers to try and so many different clients to try. And as you probably know, at the Storage Developer Conference the last 3 years, we've had a Plugfest co-located with it. Now at sambaXP, we do as well. And so that's an opportunity to get more testing in, and we encourage more and more testing of the SMB3.1.1 clients and servers. I'm not going to go into a lot of detail about the Linux kernel server. Namjae gave a talk last year for sambaXP, and you can also see some slides I got from Namjae that I presented last year at SDC 2024. I have a link to the presentation there that give you more details on the update on the Linux kernel server. But let's focus on the recent improvements in the Linux kernel client. Now, one of the things I find most exciting is multi-channel, the ability to dynamically kind of increase the number of network adapters you're using and spread I/O better across multiple NICs. Now, thank you to Sham and others for improving performance. Now, I think soon, maybe not in the 6.15 kernel, but maybe 6.16 or 6.17 will enable multi-channel by default. I mean, for cases where the server supports multiple interfaces or supports RSS, the resafe scout scaling, the performance feature that allows you to have multiple interfaces connected to, or multiple sockets connected to one NIC. But before we do that, we have to add the ability to asynchronously add channels at mount time. Right now, mount would be very slow in some cases. When I mount to my desktop at home, for example, it advertises Hyper-V interfaces, which are not reachable, so you're going to time out. So one of the things we want to do is make sure mount isn't slow, so we just connect to the primary channel and then asynchronously try to connect to the other channels without slowing down mount. Now, once that happens, I think we can turn on multi-channel by default. We've been testing it for many years, and it's very stable and it's very exciting and helps many, many workloads. Now, I also wanted to remind about an important security feature that we added last year. I'm not going to go into a lot of detail on it because we presented last year many more details on it and gave examples. But in this obsessive security world, it's important sometimes to rotate keys, to rotate passwords periodically. And that can cause problems because you don't know exactly when the server's new password is going to kick in, but you might have a reconnect occur at any time. So we added support for password 2, not just password, and also the ability to remount with password and or password 2. So you can have 2 passwords, right? One that's the current one that's going to be the new one that you're going to rotate to. And you can continue to update those passwords with switching out as old passwords expired and newer ones are added. And that was added in the 6.9 kernel, and there were some additional improvements that were added later. But I wanted to focus on this because security is one of the most important things. There's also been a lot of discussion about folios, netfs, memory management, caching, and here's a link to some of that. I wanted to thank David Howells for a lot of that work. You can see improvements to FS stress. You can see some interesting perf improvements. There's still a lot of work to do. We're still working on getting more I/O in flight for sequential reads, especially with multi-channel, better supporting cached writes, and also one of the things that David's been spending a lot of time thinking about now is how to support content crypto. Now today, obviously we can encrypt files at rest. You can mark a file as encrypted and the server will encrypt it at rest. But if you want to have the client only understand how to decrypt the file, that's a feature that he's working on now. The sort of client side encrypted um, crypto support, tying that into netfs and the VFS layer. Now, though, what is my favorite improvement though for the last year? So, we're talking about exciting new features, but my favorite is SMB3.1.1 POSIX extensions are now production ready. And as you can see from Samba, they've added support for, they've solidified support for the POSIX extensions, and that's in current Samba. And the Linux client has made some very important fixes. So keep up the testing, and I'll discuss more details in my other talk about the status of the SMB3.1.1 POSIX extensions. But I want to also remind you that as Linux continues to evolve, we can continue to evolve new SMB3.1.1 features to deal with the new syscalls and fsctls and flags. Now that earlier slide I had, 5 new syscalls, 2 new fsctls, 2 new ioctls, new flags. Not all of those, but some of those could benefit from new SMB3.1.1 features. So let's keep up the work on this. The POSIX extensions will help a lot, but we don't want to make the mistake NFS did and wait 6 or 7 years between RFCs sometimes. Now, summarizing some of the exciting changes. Back in the 6.8 kernel, there were some nice netfs folios optimizations and compounding improvements to reduce the number of round trips, improvements for special file handling. Stats can now show the timestamp of when stats began to be recorded. We have a new mount option retrans, which allows you to configure how often you're going to retry again on errors, again type errors. There are also other improvements to retry and other multi-channel improvements. Now, 6.9, we added the ability to update passwords on remount. So if session goes down, let's say, password rotation is getting common now. We allow the alt password on mount and remount to better handle the key rotation. In other words, cases where you're not sure whether the password on the server has moved to the new password or not, so you need to specify both passwords on mount. We made metadata caching improvements, and I think thanks to Matashi, we did some performance improvements for avoiding lease breaks on compounded operations. We also avoid retrying for some types of failed close operations that improve performance. We made improvements to delete of open files. We don't want to defer close, for example, if we're deleting an open file. We added a reparse mount option and added support for WSL reparse points, so better handle special files. Now in the 6.10 kernel, we added various performance improvements related to folios, that's cached I/O, and moving to use netfs more fully. So this has been a gradual process over more than a year. This movement of cifs to use the new netfs caching layer, the layer between the memory management layer and network file systems. Also in the 6.10 kernel, we re-enabled support for swap files over SMB3.1.1 mounts. We also added support for creating sockets with the SFU mount option. Now in the 6.11 kernel, we added various dynamic trace points to improve debugging. We added many important netfs folios, for improved caching, read and write, and fallocate fixes and improvements, and some important RDMA SMB direct fixes. And one of the things I'd really like to toss out there as an idea is, Long Lee a number of years ago did some great work on RDMA, and Tom Talpe and Metz and others have done some good job testing it, but we really could use more help setting up automated testing of RDMA SMB direct. And also there's been some very exciting ideas that Metz and Tom Talpe and others have shared about how to make some of this code that's currently in the kernel server and kernel client to access RDMA through SMB direct, how to make that a common library that other user space like Samba could access, but also that could make it easier for non-SMB workloads to access RDMA. In the Windows example, SMB Direct is often used as a way of just making it easy to access RDMA. With very little SMB dependency, SMB Direct can be a great way to extend the use of RDMA. And RDMA, of course, is incredibly helpful for lowering CPU use and improving performance. Now in the 6.12 support, thanks to Enzo, we added experimental compression support. We added some important DFS fixes thanks to Paolo. We improved support for special files for, in the Windows Services for Unix example, for example, we now support block, character, and symlinks better. And there were improvements to netfs again. And then as the year began, we added some kind of useful security features. We handle password rotation where passwords on the mount has just expired, but the password 2 is still valid. The password 2 on the mount is valid. There were some really important SMB3.1.1 Linux POSIX Extensions improvements. We added support for chmod over the POSIX extensions and also for query and special file types. We also added a new mount option, upcall target, to allow handling different namespaces. Remember that when you're using container workloads, you may be using a different network namespace than other workloads would. Also, a very exciting performance improvement was done to reuse deferred close file handles for writes, not just for reads. Today, deferred close is an incredibly helpful feature because it's very common to open a file, write to it, close, open it, and then read it, and then close. There's no particular reason to do that extra close and open because in many cases, immediately after the close occurs, the app is going to reopen the file. So this idea of deferred close by default, waiting a second before the close is actually sent to the server can help performance a lot with no risk. But that would benefit things like reads. So, you open a file, read or write to it, close it, and then open it again to read or query info on it, something like stat or reading the file again. That was great. It helped performance, but it didn't help if you were going to open it and write to it again. And that fix to be able to reuse deferred close file handles for writes, not just for reads, was added in the 6.13. Now in the 6.14 kernel, we added various netfs data caching enhancements and fixes, including better parallelizing reads. We added more improved reparse point special file handling. Some of that thanks to Polly's work. We also improved multi-channel channel selection thanks to Sham. That's a performance improvement for that. You can also now negotiate IA curve. So if the user space tools know how to get a ticket via this IA curve, it's sort of like a Kerberos proxy, and I think there may be some additional talks at SambaXP about the new Kerberos features. If the server requests IA curve, we can now upcall to user space, asking user space if it knows how to get the Kerberos ticket that way. So this is exciting for these new security features that are available. And I think you're going to see additional auth mechanisms added in the future. I'm also very interested that the Mac supports additional authentication options. And I think this becomes very, very important as we move to deprecating anti-LEM v2 in more and more workloads. Being able to support peer-to-peer Kerberos, being able to support Kerberos proxies, and being able to support other auth models can be very helpful as we move beyond anti-LEM v2. Now we have new mount options that were added in 6.14. We have the mount option for reparse equals none, which allows disabling using reparse points. So we won't create special files via reparse points. We also added a mount option symlink equals to allow choosing the default way that symlinks will be created for that mount. There's various ways you can create symlinks via NFS style reparse points via the way the Mac does it with MF symlinks, which in many cases I prefer. But also there's other ways, the services for Unix way. There's also other, there's a native Windows symlink format. So there's multiple ways to do that, and we can now configure which way you want to do that by default. We can still read them, the various ways, but the way you want to use to create it can be controlled with the symlink equals mount parameter. So the 615 RC is in progress now. Actually, it should be just finishing as sambaXP begins. So in 615 RC already, we've added new sudo x adders to allow retrieving just the SACL, or just the owner, or just the DACL. So there are cases where you don't have permission to retrieve all three of those. So being able to individually determine which one you're trying to retrieve via these new sudo x adders can be helpful. Not just for backup workloads, but there's cases where it's very helpful to be able to dump out the ACL information for a file. There's also improvements to the RFC 1001 handling. When you connect over port 139, you typically are using RFC 1001, and that was broken in various ways, especially to SMB1. There were a couple cases where it was broken. And there were also cases where people want to use RFC 1001 over alternate ports. So thank you, Polly, for these fixes. He also added various SMB1 fixes. You know, for me, SMB1 is not a big priority, but I realize that there's still many devices out there. So there were some useful improvements that he did for that. Also, there were some nice multi-channel fixes from Barath and others. Thank you. And Paolo has a work in progress performance improvement for improving the performance of path name processing. Very exciting time. Now, obviously, besides testing, one of the things I'm most excited about is debugging. And you know, Mitachi is going to be giving a presentation on some of the new debugging tools. You know, things like SMB Slower and others that some of them are eBPF based that let you get much better instrumentation, understanding why your workload may be slow. I also highly recommend, for those who haven't seen it, 4 years ago at Storage Developer Conference, Dr. Hani Namadi gave a great talk on the superpowers of eBPF and using those for debugging various Linux file workloads. But one of the things that's so exciting is being able to just add dynamic trace points when we find a bug. You know, to make something easier to debug in the future. We're actually just this week talking about adding a couple more for that purpose. So as we add more debugging trace points and more debugging tools, it becomes easier to analyze bugs and find performance problems and to improve, improve the customer experience using SMB3.1.1. Well, if you look compared to last year, we've added 12 more trace points. So we can very granularly turn on individually any of these trace points, and there's zero cost if they're turned off, but we now have 12 additional trace points that you can use to debug or understand your workload. They've also added ones for netfs as well. So I think there's a lot of ways that you can very cleverly analyze how your workload is performing. Now let's talk a little bit about some of the planned and in progress improvements. Now coming soon, hopefully some of these get tested at the co-located test event. One of the things that we really need to focus on, especially now that Samba and other servers support directory leases, is how do we cache directory entries more sanely? One of the things that we have today is the ability, with code that Ronnie wrote years ago, or a couple of years ago, this thing called the laundromat. We can sort of free up directories we cached periodically and periodically add more directories to our cache. So we have you maybe do an ls of the same directory twice, and we don't have to send the second ls in all the cases. And there are also cases where if you do an ls followed by a stat, that we're able to use what was cached to avoid extra round trips. That sounds great, but there's so many cases where we're not using direct releases to the fullest extent. So this is very, very important for us to look at, because saving round trips, we could literally, improve metadata performance 10 or 20% by better using direct releases. And then one of the other exciting things, and something, whenever you look at a network trace is useful to think about, is improving the use of compounding. An example that's been suggested to us that's on our to-do list is, for example, if you send 2 query ders instead of 1, when you're doing a ls, in the vast majority of cases, you save an extra round trip, because that query dir, that second query dir, is going to return no more files, but it's going to avoid the case where you basically open the directory, query the entries, then query them again and get an error. No more files, then close. It's very nice if you can do 2 query dirs, because in 95% of the cases you'll end up with saving a round trip. And one of the other exciting things that we want to focus on is supporting SMB3.1.1 over Quick. They've made a lot of progress in the kernel quick driver. When I last talked to the guys working on that, they aren't targeting for 6.15, but perhaps 6.16. There is some improvements we can do for compression support. One of the things, Jun Ma gave us experimental patches for supporting OTemp file. Temp files are something we can emulate in SMB, and it's close. It's getting ready to, we need to test it a little bit more. One of the things we've also talked about is, what about Mac OS? Samba supports VFS Fruit, so it handles the Mac OS extensions, but we should probably do this in Linux as well, because there are cases where if a server supports the Mac extensions, but not the POSIX extensions, not the Linux extensions, we can still get improved Linux interoperability by using the Mac OS, the Apple create context. And as I mentioned earlier, David Howells is working on improving content crypto. So this is not encrypting it at rest on the server. This is encrypting it on the client with keys the server might not understand. But this is going to be common code across multiple file systems. So it'll give the ability to more seamlessly encrypt a file in a way that only the authorized users on the client can see. Now, one of the other things we've talked about is support for additional auth mechanisms. As Windows moves to peer-to-peer Kerberos, local KDC, as the work that Alexander Bokovoy and others have been doing on Linux to improve support for local KDC, this will make it easier to deprecate NTLM v2 when we're not domain joined. We can use, sec equals KRB5 today, but what about cases where, you need a peer-to-peer mechanism? These new auth mechanisms you're seeing will allow us to more easily deprecate NTLM v2. And that, I think, is very, very exciting. Now, it's not just all about the kernel. It's also about user space. And I noticed one of the speakers here has done some nice work on user space tools, helping with cifs utils this past year. Now, currently we're at cifs utils version 7.3. We had to make a minor update quickly from 7.2 to 7.3 because 7.2 regressed guest mounts, which are not as common as they used to be, but we didn't want to have a regression. It also has 2 other minor fixes, but 7.2 had some very important security features that were added. But it also added support for cifs upcall to choose the type of namespace of the upcall target. It allowed setting the timeout for keys. So using the cifs cred tools, you can manage your user space keys. but sometimes you want to set the timeout for those. It also added much improved documentation. It turned out the man pages for mount.cifs were pretty out of date, although there were some improvements made in 7.1. 7.2 made quite a few more. And also in 7.2, we added support for password rotation, being able to specify password to on mount. And 7.1, they added the CLDAP ping feature to be able to find the closest site, and then added improved debugging, for example, things like SMB info, get con info. And as we talk about this, remember it's much easier in some cases to get fixes and features in cifs utils than it is in the kernel. And we have the ability to do fast pass-through fsctls, and we have the ability to do many things and that make it easier to write tools in user space. And we've considered various new tools, and we've had ideas, for example, about providing mount helpers or ways to explore what mount options are available, and then prompt that for the user and give the user choices. But we've also are very open to new debugging tools and any other user space tools that could help make SMB mounts easier to use. I think people found, for example, the ability to list the snapshots more easily, but maybe we could have a snapshot mounting tools that made that into an easier to use, saved a couple mouse clicks, saved a couple, saved a little bit of time. But we're open to more, and on the debugging front, Mitachi may have additional ideas on what debug tools that we'd love to see. But I think that please be open to contributing to cifs utils. Now, what is the most important thing of all? Obviously, security and testing. Testing, and more testing. We have the automated build bot that's been around for years, and there are hundreds of standard tests that run on a variety of servers. You can see that there. Additional tests are encouraged. We added a new test group for just focusing on Windows multi-channel. We already had one for Azure multi-channel. Now, XFS tests are the standard Linux file system functional test, FS tests. And over the last year, we added 10 additional tests to the main cifs testing regression testing group. There are now 298 tests run on every check-in from this group. We've added, various server-specific groups. We're going to be updating very soon. We're going to be updating the POSIX testing group. There are clearly some tests that now pass to Samba that we're not running in the POSIX test group today that we need to make sure we add. We test a lot with multi-channel to Azure. There are 5 more tests that added. We're up to 158 for that. For ksmbd, we have 276 tests that we're running. There's a detailed wiki page on wiki.samba that goes through how to set up, what features need to be added and enabled. But one of the things I want to also encourage is every test that is skipped or failed is an opportunity for either adding a new feature or fixing a bug. And I think that there are many cases where, obviously there's, 200 or 300 of the XFS tests that are really only applicable for a local file system like ext4 or XFS. But the majority of these tests should run over SMB. And, sometimes it's just going detail, just diving in one test at a time, saying, that's what that fallocate flag that's missing, or that's what's not being done properly. That's what's not being returned. So I do strongly encourage, looking at the XFS tests and working through ones that are skipped. There may be easy features that could be added, new fsctl flags, for example. Now the build bot's been invaluable in spotting bugs, but it was out of commission for part of last year, and we did introduce some unfortunate bugs as a result. I think you saw some netfs regressions, for example. We also are investigating alternatives like Lisa, which is helpful in Azure, and a lot of the other kernel developers use kDevOps. I think you'll find that we get automated reports from Google and Intel and others that use kDevOps internally to test SMB mounts. I know stable kernels are regularly test using KDevOps, the regularly test SMB3.1.1 mounts. That helps reduce regressions and do new features faster and improve perf. And I also should mention something extremely exciting. We do a lot of fixes every release, but in this, it's not typical to be able to backport them very well. Obviously, Red Hat and SUSE have big kernel teams, and so they can backport better. But stable kernels have typically only get 10 to 20% of the fixes and features backported. In the 6.6 kernel, the long-term stable kernel from a year and a half ago, it's extremely exciting because for the 6.6 kernel, we have like 70 or 80% of the cifs.ko fixes and features were backported. So we were able to do a lot of testing to make sure that looked good. There's still obviously lots more testing we'd love to do. There was a report today I saw, for example, about a problem on 6.6. But one of the things I want to emphasize is that the sort of stable process can be kind of broken because selectively picking patches in this automated way often leaves out dependencies that are very subtle. And so in the 6.6 kernel, we really hit a grand slam home run with cifs.ko and being able to get so many of the fixes and features backported. And we're hoping to do that with the next long-term stable kernel as well. And fortunately, there are multiple bots that run these tests regularly against stable. But we also welcome new tests, whether you add them to FS tests as general tests or whether you make cifs-specific tests or cifs-util-specific tests. We even added the various Git functional tests to our test bots last year. Now, testing is extremely important, security is extremely important, but we would also love your contributions and feedback. The future for SMB is very, very bright, and I want to thank you for your time, and I look forward to getting feedback and patches and from you all, and thank you very, very much.